Hi everyone, today I will give you an insight into how to set up rigid bodies and colliders for physics simulations and collision detection in Unity. The rigid body is a class of the Unity API which can be instantiated onto game objects. In simpler terms, a rigid body is a component which can be attached to a game object. This component enables physics calculations to be performed on the specific game object, which means that the object can now react to the in-game physics such as gravity, and to other physics objects, provided they all have a collider component, which we will cover in a moment. Thus, in summary, once a game object has a rigid body component attached, it can be subjected to forces, torques, and other physics phenomena, just like an object in the real world. Colliders are also components that can be attached to a game object. Colliders allow the object itself to interact with other objects, provided they all have a collider component attached. A collider can be attached to a game object by itself, but it usually comes in pair with a rigid body. I will cover this in more detail later in the video. It is fundamental to understand that colliders alone do not allow a game object to react to physics. This is the rigid bodies function. At the same time, rigid bodies alone do not allow game objects to detect collisions, since this is the colliders function. There are three main types of rigid body and collider combinations. We're not going to focus on triggers in this video. First, we have the static collider. This is a simple collider attached to a game object without any rigid body component. Second, we have the rigid body collider. This is a game object which has a rigid body and at least one collider attached. Third, we have the kinematic rigid body collider. This is the same as a rigid body collider game object, with the important difference that the isKinematic checkbox on the rigid body component is ticked. Now let's focus on each of them one by one, covering their most important features. A static collider should be used on static game objects. These are objects which do not move in the scene by any means. They are anchored and have a fixed transform the whole time. Since the object is not moving, it does not necessarily require a rigid body component. This is because the rigid body component allows for complex physics movement calculations, which are not really required for our static object. Moreover, moving a static collider object results in erroneous physics calculations and large performance hit on the physics engine, since additional computations will have to be performed to solve the interactions due to the absence of a rigid body component on the static game object itself. A rigid body collider is a game object which has both a rigid body and a collider. The rigid body is not marked as isKinematic. This object can move based on the interaction with other static colliders, rigid body colliders, and kinematic rigid body colliders. It is the most straightforward physics object that you can have in Unity, since it is pretty much affected by any disturbance from other physics objects. If you want to move a rigid body collider, you should never do this via its transform. This is because one of the functions of the rigid body component is to update the transform based on physics interactions. Changing the transform directly will result in jittering, as both rigid body and transform components will want to update the transform of the object, thus fighting each other and giving different outputs. You can apply forces and torques to a rigid body collider to change its transform using the appropriate functions provided by the Unity API, for example, RigidBody.addForce. And at the same time, interaction with other physics objects will also influence its transform. Finally, we have the kinematic rigid body collider. A kinematic rigid body collider is the same as a rigid body collider in terms of components. So we still have a rigid body component and a collider component attached to our game object, but with the important difference of having the isKinematic field or checkbox set to true. On the other hand, it behaves nothing like a rigid body collider. This is because the isKinematic field allows it to interact or influence other rigid body colliders, but it prevents it from being affected by them. This behavior is similar to that of the static collider, with the difference that we can have an efficient moving object. In this case, we can equally choose to move it through its transform methods or rigid body methods. One could say that in this case, directly changing the transform is also okay because the game object does not react to physics because it's kinematic. Therefore, the rigid body component won't actively try to change the transform, which introduces no conflicts. On the other hand, this may cause problems when our kinematic rigid body collider comes into contact with other rigid body colliders. In fact, moving the kinematic rigid body collider using the transform causes spikes in the game object's acceleration over frame, which may result in other physics objects being launched away in the scene due to a peak collision force. I hope this was a useful insight or overview into Unity's physics. Now, there are many more topics to be covered, which I left out on purpose, such as dealing with the fixed update when using the physics, or talking about compound colliders, or even talking about collision or trigger events. But if you guys want, I can cover them in future videos. So for now, thanks for watching and see you next time.